Welcome back. In our last video, we saw how to create generic datasets using Python lists. Today, we'll see how to apply transformations on those datasets, but before that, we have to clear the air on certain functions. You may remember the function call from tensor slices or from tensors that we used yesterday to create the datasets. But what is happening behind these codes? What are we slicing? Well, let's explore. Now, tensors are objects that can be used to structure the data in a specific manner. They are broadly classified based on their ranks. How do these tensors get their ranks? It's because of their dimensions. Tensors with lower ranks even have different names that we will see in a few seconds. A rank 0 tensor has no dimension, just like a point in space. But they do have their own magnitude, that is, a size. How is it possible? Just an infinitely small point in space having their own magnitude. Now, just imagine an electric charge that is present in the space. It does have a charge, even if it is infinitely small. Even though it does not have a direction, it has its own magnitude. A rank 1 tensor does have a direction, but only in one dimension. So if you're going to walk on that red color arrow, you're only going to take either your left side or right side. You just can't jump out of the line. So it's just one dimension. A rank 2 tensor has 2 dimensions. It's just like a continuously long infinite plane. So you can walk anywhere out there into the plane, but you just can't jump out of the plane. Or you cannot fly up above the plane. Now, as you have imagined, rank 3 tensors have 3 dimensions, meaning you can walk in any direction you want and jump as high as possible, or fly around the plane if you have a good set of wings. Now let's try to go a little bit further. It is impossible for us to imagine a 4th dimension, but numerically speaking, we can just pile up the rank 3 tensors together in a way that they form a rank 4 tensor. This would make more sense when we look at the numerical data. So now let's compare these to the type of numerical data that we will be using throughout the code. So remember, the ranks of these tensors talk about how many dimensions they have. So the rank 0 tensor can also be called as a scalar. This naming kind of makes more sense because if you take a scalar like 3 and apply it to a chocolate, you will get 3 chocolates. In other words, it has scaled the number of chocolates you had previously. Now you can note that the shape of the scalar has nil inside the parenthesis because it has no dimension. Now a rank 1 tensor can be called as a row vector. Here is an example of how a row vector of shape 3 will be. Now here we have 3 elements inside a single row, hence the shape 3. A rank 2 tensor can be a matrix. A column vector is also a perfect example because it can also be thought of as a matrix with a shape 3 into 1. That is 3 rows, and 1 column. Right. Another example here is a 2 by 3 matrix. That is with the shape 2 by 3, 2 rows, 3 columns, 2 rows and 3 columns. So I think you would have understood the pattern by now. The rank 3 tensor now follows a similar fashion. The rank 1 vector has 3 scalars, if you look carefully. So you took 3 scalars and packed it inside one bracket. Now the rank 2 tensor has taken row vectors and enclosed them within green brackets. So you see for 1 dimension you have a single bracket and for 2 dimensions you have 2 brackets. So similarly, in a rank 3 tensor, you have taken 2 matrices, that is rank 2 tensors, and you have enclosed them within a purple bracket. So do you see the pattern in here? The number of opening brackets at the beginning kind of actually gives away the amount of dimensions that the tensor shape has. Here we can see 2 brackets, so rank 2. 1 bracket, so rank 1. 3 brackets, so rank 3. So for rank 3, we can read the shape as a 3D tensor with two 2 by 3 matrices. I repeat, 3D tensor with two 2 by 3 matrices. So similarly, for rank 4, you can read the shape as 4D tensor is a 4D tensor with 5 3D matrices. I repeat, it's a 4D tensor with 5 3D matrices. So this is how tensors work. You can apply the same format for tensors of higher dimensions. So even though it was a little inconvenient for us to think about it in terms of space for the higher dimensions, it becomes easier with these bracket notations to think of them of different dimensions. Enough of theory. Let's get our hands dirty. As you know already, the first step is to import TensorFlow. Now, as I've already imported TensorFlow in my Jupyter notebook, I'm not going to do that again. The next step is to find out the differences between from tensor slices function and from tensor function. So creating a data set can be done by either of these two commands, but knowing the difference is crucial. Now take a look at this tensor right here. By the bracket notation, you might have already figured out that this tensor is now 3-dimensional because 3 opening brackets. So what does from tensor slices do? It is going to slice off from the first dimension, that is this bracket, meaning it will take away the first dimension. So it will take away the first dimension and all the individual elements in it will be considered as separate elements for the dataset. So this one entirely big 3D tensor will become smaller 2D tensors. So let's try that now. I have run the cell and I'm going to run a for loop through it inside each element of the dataset, and I'm going to find out how many elements are there inside the dataset. So we have 2 separate elements now. You can see there is a shape 2, 3, that is 2 rows, 3 columns matrix, and another 2 row, 3 column matrix inside the dataset now. So we have taken a single 3-dimensional tensor and we sliced it off of the first dimension, and we have 2 separate tensors inside our dataset now. Now imagine we are not going to do that. We're going to take away the slicers operation and we are going to introduce the from tensors operation. Now what exactly happens? Let's rerun the code and try to print out the elements inside the dataset. I think you have guessed what happened. This function, that is from tensors function, will not remove any dimension from the input tensor. It will take the entire input tensor and it will give it to the dataset. So you have only one tensor of the shape 2 by 2 by 3 inside the dataset. So there is only one element inside the dataset. I hope that clears things up. Now let's go ahead and try to apply a transformation. Here I have a new dataset, and the dataset is actually the range of all numbers till 100. So as Python is 0 indexed, it is going to start from 0 and then it's going to go all the way up till 99. So this dataset here will have all numbers from 0 to 99 included. And I'm going to write a function called a dataset function, and it's going to take an argument a different dataset, that is this dataset that I'm going to pass in later. And this function will return a filter. Now, what is a filter? This filter will only filter out the data inside the dataset or the elements inside the dataset when it satisfies the condition that we are giving it. So what is the condition that am I giving here right now? The condition that I'm giving here is the dataset element X should be less than 5. Out of all these 100 elements, out of all these 100 elements, I'm only going to need the elements that are less than 5. If this condition satisfies, then filter out that data and give it to me. That is what is going to happen in this function. So let's run that. Now I'm going to apply the transformation to the dataset. So remember, we only defined the function and we defined the dataset. We never really applied the function to the dataset to get the transformation. So the next step is going to be applying the function to the dataset. That is done by, who would have thought, apply method. So I'm going to give in the function that is going to be applied to the dataset inside the argument of apply method. So I have run the statement. So let's see what the results are going to be. As usual, I'm going to print out all the elements inside the dataset. Remember, this dataset initially had 100 elements starting from 0 to 99. Now, after applying the function called dataset fn, what would happen to the dataset? We have only got those values that are less than 5. So this dataset now has 5 different elements of no shape, meaning they are all scalars. And all these scalars are less than 5 because of the condition we just applied. So this is kind of a transformation that we have done to the initial dataset. And thank you for watching.